Here are the answers for the Chapter 4 study guide. So, first section was solve each equation, check your solution for extraneous solutions. So we should plug everything back in to make sure it works, or you could have graphed it to make sure it worked. For the first problem, the first thing that I did was add 5 to both sides. So we had negative 3 groups of x minus 4 squared equals negative 48 divided by negative 3. I get x minus 4 squared equals 16. Square root of 16. I get x minus 4 equals 4. Or x minus 4 equals negative 4. So when I solved, I ended up with x equals 8 or x equals 0. When you plug 0 back in, you end up with negative 53. Same thing when you plug 8 back in. So both of them are solutions. Problem number 2, the first thing I did was square both sides. So I got 3 minus 2x equals 49. Subtract 3. Negative 2x equals 46. I ended up with x equaling negative 23. When I plug that back in, I got 7. So it is a solution. For 3, it's an absolute value problem, so I have to separate it into 2. So I do 3x minus 4 equals 14, and 3x minus 4 equals negative 14. Added 4 for both of them. So we had 3x equals 18, or x equals 6. 3x equals negative 10. So x would equal negative 10 over 3. Plug them both back in. They both work. So both of them are solutions. For the next one, I started to solve it by squaring both sides. In order to do that, I would get x plus 4 equals, I made a box for the next one to get 64 plus 2 the square root of x, plus 8, plus 16 the square root of x. Plus x, and at that point I realized, okay, I have a square root in the middle. I'm not going to know how to solve that, so then I graphed them in Desmos, and it turns out that there's no solution. This one I started off by multiplying it out, so I got x squared plus 8x plus 16 plus 5 equals 2x. So I simplified, I subtracted the 2x, and combined like terms and got x squared plus 6x plus 21 equals 0. And then I attempted to factor it, and it's unfactorable. So before I plugged it into the quadratic formula, I graphed it, and it turns out this one is also no solution. And then for 5, I started by subtracting 5 from both sides. I got negative 8, the absolute value of negative 2n equals negative 80. I got negative 2x equals 10, or negative 2x equals negative 10. So I know that my answers are x equals negative 5 or 5. When I plug them both back in, they both work. The next problem says solve each of the following inequalities, express the solutions algebraically and on a number line. So the first thing I'm going to do in this one is subtract 12 from both sides. So I solve this if they were an equal sign. So I'm going to end up with 3x minus 5 equals 7, or 3x minus 5 equals negative 7. So we get 3x equals 12. So x equals 4. 3x equals negative 2, or x equals negative 2/3. So In order to figure out what the actual solution is, I have to graph it and use my boundary points. So it's a closed circle at 4 and a closed circle at -2/3. So I use 0 to plug back in. When I plugged back in 0, I got 9 minus 5 is 2. 14 is less than or equal to 19, so it was true. I plugged in 1. 3 minus 5 is -2. 14, or -1, sorry. It'd be -8. 8 plus is 20, which is not. So this side didn't when I plugged in -1. This side did not work. 0 did work. If I plug in 5, I get 15, 10. 10 plus 12 is 22. So 5 didn't work as either. So the answer is between the two. So I write it out as an inequality as -2/3 is less than or equal to x, which is less than or equal to 4. And the number line and the inequality is my solution. For problem number 8, I started by moving everything over to the other side. So I subtracted 3x squared and added 2x. So I ended up with 2x squared minus x minus 6 is greater than 0. So then I factored it and got 2x plus 3 and x minus 2. Because it would be -4 and a +3 is equal to 0. So my boundary points are going to be -3/2 or 2. So again, I'm going to graph them. It's an open circle this time because it's only greater than and not greater than or equal to. So I put a dot at -2. Open circle at both of those. This is -1, -2, -1.5. So then I pick 0 again as a point. I'm going to pick 3 and -2. So 0, when I plug it back in, I end up with -6 is greater than 0, which is not true. So I know that this isn't true. 3, when I plug it back in, I get 9, 18. 18 minus 9 is 9, minus 6 is 3, which is greater than 0. So this part worked. So I know that I have this. And then when I plug in -2, I get 4 times 2 is 8 plus 2, which would be 10 minus 6 is 4. So that works as well. So this is my number line, but my inequalities are x is less than -3/2 or x is greater than 2. Next problem told me to solve graphically. So again, I used Desmos. When I did it, if I was to sketch my graph, I ended up with a parabola that looked kind of like this. And I ended up with an exponential that looked kind of like this. So they had 2 points. Notice my graph is nowhere near where it's supposed to be. So x would equal 1 or it equaled -3.56. Problem number 10, we had to write a rule. So right away I noticed that this was going up by +3 each time. So I know it's a linear rule or arithmetic. So I would just write so T of n is equal to, I know it's 3 times n, and then 1 is 1, so I go back 3 to get -2, so it's -2. In this one, I noticed that I'm multiplying by something, so I'm multiplying by 1/2, so it's exponential. So T of n is going to equal, I know my multiplier is 1/2, and then I divide by 1/2, 3 divided by 1/2 is 6, so it's 6 times 1/2 to the x. So the next question, it says find an explicit rule for an arithmetic sequence based on the information. So I figured out what it was growing by, or actually going down by. So 17 to 3, it was 2 away, so it's going by 7. So the next one would be 10, and this one would be -4. My initial value going back would be 24. So it's going to be T of n equals a -7n plus 24. The next ones, I'm solving for the variable. So in this one, I'm going to move the 5x over. So negative 3y equals negative 5x plus 12 divided by negative 3. Y equals positive 5/3 x minus 4. For the next one, the first thing I did was multiply by r squared. So I have f times r squared equals g m sub 1 m sub 2. So I divide by g m sub 1. So my final answer is f over f r squared over g m sub 1 equals m sub 2. I'm solving for m in this one. So the first thing I'm going to do is multiply both sides by 2. So I get 2e equals mv squared, and then divide by v squared. So final answer, 2e over v squared equals m. And 16, I'm solving for y. So I want to get rid of the x. So first I subtracted x minus 4 squared from both sides. So now I have y plus 1 squared equals 10 minus x minus 4 squared. So then I take the square root of both sides. Y plus 1 equals plus or minus the square root of 10 minus x minus 4 squared. And I subtract, oh, there was y minus 1. Sorry about that. So I add 1 to both sides. So my final answer is y equals 1 plus or minus the square root 10 minus x minus 4 squared. So my last problem set is I'm multiplying, dividing, adding, or subtraction to get a simplified expression. So for the first one, I'm going to factor everything. So the top I factor out of 3. So I get 2x plus 1. Bottom, nothing can factor, so I have 2x minus 3. Change it to multiplication, so I factor the bottom. I end up with 2x minus 3 and x plus 1. Then the bottom, the top I can actually pull out of 3. So x squared minus 4x minus 5. So then I rewrite it, so 3, 2x plus 1. 2x minus 3. So I factor, I get x minus 5x plus 1. So now that I factored everything, I cross things out if I can. I can get rid of this 2x minus 3. I can get rid of the 3's. I can get rid of the x plus 1's. So my final answer is 2x plus 1 over x minus 5. The next one I'm adding. So the first thing I have to do is find a common denominator. So I notice that I'm actually subtracting. So I can multiply this side by m minus 4. And on this side, I can multiply by m plus 3. So on the top, I'm going to get 5m squared minus 20m minus, on the other side, I'm going to get 2m squared. So I get 5m, 6, so 11m plus 15 all over m minus 4, m plus 3. So then I simplify 5m squared, so I get 3m squared. Negative 20 minus 11 is 31m. And then minus 15. Over m minus 4 n plus 3. So then the next thing I do is I attempt to factor it. So I attempt to factor the top. And I need to get a positive and a minus. So the only way to do that would be for it to be the positive to be way bigger. So I think the top's probably unfactorable. So I'm just going to leave this as my answer. For the next one, I'm multiplying. So I'm going to factor everything first. So when I factor the top, I get 5x minus 1 times x minus 2, x plus 4 times x plus 4. For the other side, I get x plus 6 times x plus 4 over 5x minus 1 and 2x plus 3. So then I simplify. I can cross out an x plus 4 and an x plus 4, 5x, and that's it. So my final answer is x minus 2 times x plus 6 over x plus 4 times 2x plus 3. And then the last problem, I'm subtracting, and my denominators are already the same, so I'm just going to subtract straight across. So I get 3a squared minus 2a squared, or a squared. A minus negative a is going to be positive 2a, and negative 1 minus 2 is going to be negative 3. So I'm going to see if I can simplify anything. I factored the top, and I got a plus 3, a minus 1, over a minus 1 times a minus 1. So these cancel out. My final answer is a plus 3 over a minus 1.